Okay, so we have the next topic, which is the hyperbola. Okay, so I already have here a graph of the hyperbola. The hyperbola is the red line. Okay, this one. Right. So this one and this one. Those that is a hyperbola. So you can see it still has two focuses and two vertices. Okay, one center of course, and then four latus rectum. Okay, so the distance we also have here, which is the asymptote. Okay, that's the asymptote that we're the asymptote is the line that guides the hyperbola. But as you can see, this is the hyperbola and the asymptote will all just go longer and longer, but they will never meet. Okay, and what else? So we have here. I will zoom it a little. Okay, so this will be A and this will be B. Okay? And then C will be its hypotenuse. So you will have here a relationship something like this. So C squared is equal to A squared plus B squared. Okay, next. Okay, so we have here the formulas for hyperbola, which is the transverse axis, that's the V2 V vertex to vertex, so from here to here, that's 2a, right? And then the conjugate axis, or that B2, so from here to here, that's 2b, that's the conjugate axis. So the general form now is, as you can see in ellipse, the coefficient of x squared and y squared are no longer equal, but it is positive. The y squared is positive, and now it will be now negative. Okay? So again, if it's equal, it will be a circle. So ax squared minus by squared plus 6x plus dy plus b equal to 0. So the standard form is just the same with the ellipse. The only difference is this is negative. Okay, this is negative. So we have the transverse axis, which is horizontal. Okay, and then we have here y minus k squared, which is the transverse axis, will be the vertical. So recalling the ellipse, the major axis, you can determine the major axis where the a squared will be. If the a squared is with dx, therefore the major axis is um, horizontal, and then if the a squared is with y, therefore the major axis is at the vertical. Okay, and but here what you will be looking for is whichever the positive, whichever the between x squared and y squared is a positive, that will be the transverse axis. So as you can see here, the positive is the x squared, right? But the y squared is negative. Therefore, the transverse axis will be at the horizontal. And if the y squared is the positive again and x squared will be negative, the transverse axis will be the vertical. So this is at the center 0, 0 or origin. So you just the k and h will just be removed, but the principle is just the same. Okay, and now the properties. So of course, the eccentricity of the hyperbola is greater than 1. E is still the same, E is equal to c over a, but the c is slightly different. It will now be c squared equal to a squared plus b squared. Latus rectum and the d are still the same. Okay, so this is the I think I forgot to say that this d is the directrix. Okay. So angle between asymptote, you can also find that is just the phi or theta, whatever angle is that. P is equal to 2 arctan of b over a. And to locate the equation of asymptotes, all you have to do is to replace 1 in standard form by 0. Okay, so going back, this is the standard form, right? So you will replace now 1 with 0. Okay, so it will now become equal to 0, and then solve for y in terms of x. That's it. So you will be able to get two equations for that. Okay, so we'll be solving a problem regarding that. So note the point of intersection between the asymptote, it is the center of the hyperbola. So you can see the intersection of the asymptote, again this is the asymptote, okay? The intersection of those will be the center. Okay? So you can just equate each other, the two asymptotes to each other, and then you'll find the equation of the center. That's also a trick that you can do. So with that, let's move on to some problems. Okay, so let's go to the some examples of hyperbola. Okay, so for number one, so we have given is a parabola of x squared minus 3y squared minus 4x plus 6y minus 2 equal to 0. So find the length of its latera recta. So again, we have to reduce this into its standard form. So again, so what will happen here is, so x squared minus 4x, right? And then um, minus, I will factor out the negative. So you will have your 3y squared minus 6y. Okay? And then the negative 2 will be transposed on the other side. So x squared minus 4x minus, you can factor out 3, right? So you'll have your y squared minus 2y equal to 2. Okay, and then let's do completing the square or CTS. So x squared minus 4x plus 4 minus 3 times y squared minus 2y. So 2 divided, so plus 1, right? Plus 1 equal to 2. And then you'll have here, this is x minus 2 squared. And then this is minus 3. Actually, I forgot to add on the right side. So I still have to add here plus 4 and then um, minus 1 times negative 3, right? So minus 3. Okay, so you'll have here x minus 2 squared and then minus 3 times this is y minus 1 squared. And this will become 3. So divide all by 3. So you'll have your negative 2 squared all over 3 and then minus y minus 1 squared all equal to 1. Okay. So we can now compute for the latera recta. So with that, the A will be 3. No. A squared, right? A squared will be 3. Therefore, A is equal to square root of 3. And then B squared is equal to 1. B equal to 1. And then we can also have that the center, okay, center is at, by comparison, that will become 2 and 1. Okay, so this one and then this one, so you have to change the signs. And then what else? We have to find the latera recta. So latera recta is LR equal to 2b squared, right? 2b squared over a. So this is equal to 2 times 1. B squared is 1 and a is square root of 3. So this is just 2 over square root of 3. The next is b equal, what's b? Eccentricity. So e is still equal to c over a. Okay? But remember that c here is the c squared is equal to a squared plus b squared, right? So here you can replace c by square root of a squared plus b squared all over a. So this is square root of a squared is 3 plus 1 all over a is square root of 3. So this is square root of 4, so this is 2 square root of 3. So this is the answer. This is also an answer. So letter C, the distance between directrices. So distance between directrices, that is D is equal to A over E, right? So A is equal, actually A and E is equal to C over A, right? So this is C over A. So this is A squared over C, or square root of a squared plus b squared, a squared. So this is a squared is 3, right? So 3 square root of 3 plus 1. So this is 3 over 2, right? That's 3 over 2, but you have to times that by 2. So that's between, so 2d equal to um 2 times 3 over 2. Okay, so cancel out 2, so the answer is just 3. Okay. What else? Letter D is the angles between asymptotes, that is the arctan, right? 2 arctan b over a. So letter D is P is equal to 2 arctan b over a. So b is 1 and a is equal to 3. So let me see if I have a answer for that. That is 60. Oh no, it's b. It's a, so it must be square root. So this is 60 degrees. Yeah. Okay. And letter E, I think that's the equation of asymptotes, right? Equation of asymptotes. So for the equation of asymptotes, all you have to do is to rewrite the equation that we got, that is x minus 2. Okay. That is x minus 2 squared all over 3 minus that is y minus 1. Y minus 1 squared equal to 1. And then this is letter E, right? This is letter E. So what we wanna do is we have to change 1 into 0 and then find the value for y in terms of x. So you'll have here x squared 3 minus y minus 1 squared equal to 0. So you will have here x minus 2 cube and then transpose y minus 1 squared, therefore that will become negative, and then times 3. There you go. And then let's get the square root of both sides. You'll have x minus 2 equal to the square root of 3 times y minus 1. Okay? So you'll have here x minus 2 all over square root of 3, right? Equal to y minus 1. And then actually when we square root, you have to put here plus or minus, right? So you'll have here plus or minus here. And then transpose the 1, you'll have your y is just equal to x minus 2 plus or minus square root of 3 plus 1. So this will be the equations of the asymptotes. So I think that's it for the number 1, right? Okay, let's move on to now to the next number. Okay, so for number 2, we have locate the vertices of the hyperbola xy equal to 4. So that is actually a special case for hyperbola. So for number 2, you'll have here xy equal to 4. That is actually a rectangular hyperbola. Okay. So if I will graph that, this is what it actually looks like. So this is the Cartesian plane, and the parabola will look like something like this. So if this is the first parabola, okay, and then this is the, so that is a parabola. So what will actually happen here is okay, if you will consider this line, this is actually the line. This line actually passes through the origin. So that is 0, 0. And this line will also be the line that bisects the first and the third quadrant. Therefore, you can say that this line is x equal to y. Okay? So, if x is equal to y and xy is equal to 4, okay, so substitute that, though you'll have your x squared equal to 4. So, if you get that, you'll have x equal to positive or minus 2. Okay? Therefore, if that is x, y will be equal to positive and negative 2 also. Therefore, the vertices will be, partners will be, you have your positive and negative 2, so that will be 2, 2, and the other vertex is negative 2 and negative 2. So this will be your answer. Okay. So let's move on to the next topic.